Hello and welcome ladies and gentlemen to this new virtual school. New way of learning and teaching, with the vision of let's grow together. Our mission is to learn how to learn and teach how to teach. We'll make you aware of the world around you in an easy way of learning. On this platform we'll be uploading current happenings around the world. Science and technology, political science, and international relations, climate change, sustainable development, environment and many more. Do like, share and comment. Press the subscribe button and hit the bell icon to get new notifications. So here we go.
Our mission is to learn how to learn and teach how to teach. So stay tuned. And here we go. Science and technology. The goal of vaccines is to prevent severe disease and deaths. Gagandeep Khan Special Arrangement. R. Prasad. After approving Covishield vaccination with a 4-6-week interval between two doses despite evidence showing higher protection when the gap was more than 12 weeks, India changed the interval to 6-8 weeks on March 22 when shortage of vaccines became apparent. With shortage of vaccines becoming more acute since then, on May 13, India once again changed the gap between two doses to 12 to 16 weeks even as highly transmissive variants were widespread in India. Dr. Gagandeep Khan, Professor of Microbiology at CMC Vellore, explains the implications of the changes made in the midst of the second wave. India approved Covishield with an interval of 4-6 weeks between two doses despite the MHRA approving AstraZeneca with 4 to 12 weeks gap and JCVI approving a 12-week prime boost interval. What was the Indian drug regulator's rationale for deciding the second dose schedule for 6 weeks after the first dose? The Indian regulator's rationale for deciding the second dose schedule at an interval of 4 to 6 weeks was based on what had been done in the clinical trials that were conducted in India. A paper in The Lancet based on a pooled analysis of 4 randomized trials found vaccine efficacy reached 82.4% when the second dose was given 12 weeks after the first but only about 55% when given less than 6 weeks after the first dose. So why did India not increase the interval between two doses to 12 weeks in early February? In my opinion, India should have increased the interval between two doses to 12 weeks in February. However, the committees that decide on policy for India were clearly unconvinced that a 12-week gap was supported by evidence. What evidence was available for India to change the interval between two doses to 6-8 weeks on March 22? From the clinical trials and the real-world evidence that was available by mid-March, there was no data that distinguished between specifically periods up to 8 weeks and those beyond 8 weeks. On May 13, the government changed the interval between doses to 12 to 16 weeks based on real-life evidence. But even in the UK the interval was only up to 12 weeks. So where did the government get real-life evidence to change it to 12 to 16 weeks? As far as I am aware, the only data that is available beyond a period of 12 weeks is the data from the phase 3 clinical trials. Spain and Canada had proposed longer intervals, but I am not aware of real-world data from those settings. According to a May 24 preprint, in the UK, the effectiveness of a single dose of AstraZeneca Covishield was only 33.5% against the B.1.617.2 variant and 51.1% against the B.1.1.7 variant. After the second dose, the protection increased to 59.8% against the B.1.617.2 variant and 87.9% against the B.1.1.7 variant. With the B.1.617 and B.1.1.7 variants being the most prevalent in India, should we not be reducing the gap between two doses, especially since the protection against B.1.617 from the first dose is just 33.5%. I think it is important to emphasize that the report from the UK which shows variant-specific protection is only against all symptomatic infection and does not consider severe disease. Since the goal of vaccines is to prevent severe disease and deaths, either from India or from the UK, we should be generating the data that tells us how well vaccines are performing with a single dose against severe disease. The UK decision on shortening the interval is not based on available evidence but does rely on the fact that they have immunized all adults with the first dose and have supplies to be able to vaccinate their population with the second dose. Since the B.1.617.2 variant is fast spreading in the UK, The government has reduced the gap between 2 doses to 8 weeks in those over 50 years and the clinically vulnerable population. Under these circumstances, what is the justification for India to increase the interval between doses to 12 to 16 weeks? There are two ways to make a decision. One is to have data to support the decision. Currently, no country has data to inform how well vaccines work with an 8-week gap. In fact, given that India was the only country to have a 6-8 week gap between doses from March, and in above 60 years, we could potentially be able to provide that data to the world. The second way to make a decision is to model different scenarios that can be varied for predictive vaccine performance against variants and use that to decide whether and what policy change is required. I assume the UK did this. I am not aware that we have any data or any model that states that the decision was incorrect. How much real-world data are available to support a gap of 12 to 16 weeks for Covishield when B.1.617 variant is widespread? None. Though the first dose of Covishield has 51.1% against the B.1.1.7 variant, the second dose increases the protection to 87.9%. Since B.1.1.7 variant 2 is widespread in India, is it correct to increase the gap between 2 doses? Against severe disease, a single dose of AstraZeneca vaccine has 80% protection. If the goal is to prevent severe disease, then it makes sense to use available doses to immunize more people with the single dose. For me, in the absence of evidence of performance of a single dose against severe disease due to B.1.617.2, I would be reluctant to change at a time when we still have intense transmission, and the opportunity to modify disease severity in a larger population with the single dose. Is the logic of partially protecting more people with the single dose than increasing the level of protection in fewer people correct, given that the first dose is only 33.5% protective against the B.1.617.2 variant, which is the most prevalent in India today? Once again, these data are for all symptomatic infections. We have not reached a stage in vaccination where we are trying to prevent all disease or all infection. Will a partially protective, 33.5% single dose lead to the generation of vaccine escape variants? No. Protection is not measured at the level of the individual, but at the level of the population. Vaccine escape variants could be generated in persons in whom the virus can continue to replicate and mutate in the presence of antibodies. Considering the shortage, can people already infected receive 2 doses at 12 to 16 weeks while the rest get it at 8 to 12 weeks interval? Previously infected people have some protection. We do not know yet whether they might be equally protected with just a single dose. However, for the program to vary schedule based on history of infection is difficult. IIT Mandi researchers reveal SARS-CoV-2 protein structure. Defense Trust from India. Researchers at the Indian Institute of Technology, Mandi, IIT Mandi, in Himachal Pradesh have revealed the part of structure of a key protein in COVID-19 virus, which helps in understanding its mode of action, its role in the spread and severity of the disease and development of antiviral therapeutics. The findings have been published in current research in virological science. One route to neutralizing any virus is to attack its proteins. Such an approach holds true for the COVID-19 virus as well, and scientists across the globe are involved in studies to elucidate the structure and functions of these proteins to understand the viral disease and develop drugs that are effective against the virus, said Rajneesh Giri, Assistant Professor of Biotechnology, IIT Mandi. This virus has 16 non-structural proteins, NSP1 NSP16, of which the NSP1 plays a vital role in the pathogenicity, ability to cause disease, of the virus. The NSP1 disrupts the proteins of the host cell and suppresses its immune functions. Its importance can be understood by the fact that it is also called the host shutoff factor. Earlier in 2020, we have shown through bioinformatics studies that NSP1 C-terminal region has intrinsic disorder propensity between 0.4 to 0.5 scales, very close to borderline of intrinsic disorder prediction. However, without experimental studies, we were not sure that this 13 to 180 amino acid region is actually an intrinsically disordered protein region. Generally, these regions are unfolded in in solution but are folded into particular conformations when binding with specific molecules or partners inside the host cells, said Giri, explaining the recent developments to his previous research. The IIT Mandi team has experimentally studied the structural conformations of SARS-CoV-2 NSP1 under various conditions in an organic solvent, membrane-mimetic environment and inside liposomes. The researchers have shown the dynamic changes in the conformation of the IDR of the NSP1 in response to its surroundings, due to hydrophobic and electrostatic interactions between the protein and the environment. The other members of the team include IIT Mandi research scholars Amit Kumar, Ankur Kumar and Prateek Kumar, along with Neha Garg from the Banaras Hindu University. Thank you. Thank you so much for watching this video as podcast. Do like, share and comment. Press the subscribe button and hit the bell icon to get new notifications. Thank you. Take care and stay safe. God bless you all. Jai Maa Bharti. To download news and editorials in MP3, follow us on Telegram, Virtual School. The link is provided in the description below.